Welcome to the seminar Change Driving Ideas Today, the Norm in Construction Tomorrow, held by the Swedish innovation program Smart Built Environment. My name is Cristina Lazaro and I will be moderating today's event that will focus on 3 innovative projects that have been tested and implemented within the program. These 3 projects are in the fields of generative design, sustainability, artificial intelligence and digital twins, and make a real impact in today's society, economy and environment. Digitalization of the built environment has entailed major advancements and new technologies such as geographic information systems and building information modeling. That as well with industrial processes lay the foundation for the program's core. Within the built environment sector, there is enormous potential to exploit the opportunities that digitalization entail by changing structures and ways of working in order to contribute to a more sustainable, efficient and profitable built environment. The program gathers the different actors in the sector because only together we can achieve sustainable environments, manage our resources more efficiently and reduce carbon emissions. The built environment sector is by far the largest sector in Sweden. It consists of a variety of actors that need to cooperate. We believe that we need a partly new way of thinking in order to overcome the major challenges that are ahead, both for our sector but for the society as a whole. When it comes to, for example, sustainability, climate, rising construction costs, decarbonization requirements, and so on. To be able to create a more sustainable, smarter, and better built environment, we need both new tools that are data-driven, digital, and connected. We need a new mindset based on circularity, sustainability, longevity, and robustness. And we also need new ways of working and new business models within the sector. We believe that smart built environment can lay the foundation for this, and that international cooperation and international partnerships is a huge advantage and almost a prerequisite to achieve this in the future. A quick facts about the program so far. Smart Built Environment is a 12-year strategic program that started in 2016 and is going to last until 2028. We are currently in program period number 3. The program gathers more than 100 companies and organizations from the Triple Helix. We have over 200 ongoing or completed projects and over 350 active project stakeholders. The total project funding for this year is 60 million Swedish crowns with an equivalent amount of co-financing. The program has, of course, also its long-term goals that it plans to achieve by 2030. The first one goes along the lines of circularity. By 2030, the program wants to achieve a circular resource management and more efficient processes in terms of both costs and time from planning to long-term maintenance and management. By 2030, the program also is characterized, the quality of the built environment is characterized by functional durability, aesthetic design, longevity and robustness. By 2030, the program will also have achieved a clear reduction of greenhouse emissions in compliance with Sweden's climate targets for 2030. And last but not least, the program also aims at achieving new value chains and business logic based on life cycle perspective, platforms and new stakeholder constellations. In order to achieve these long-term goals, the program uses 3 types of tools. On the one hand, we have strategic initiatives and also open calls, which are divided in 2 different calls. If we take the first one, strategic initiatives, these initiatives are strategic projects that are initiated by the program board. And they have a clear strategic focus and also have a long-term horizon. It's targeted initiatives that have clear benefits for a lot of stakeholders in the sector, and they are built in an open process together with the sector's actors. Then we have the open calls. We have 2 types of open calls. We have an annual open call, which is a broad one, and we also have what is called innovation call, which is focused on innovative ideas. If we look at the annual open call, this one is a broad call covering all of Smart Built Environment's thematic areas, which are information infrastructure, business models and new value chains, new knowledge and expertise, and innovations and new ideas. These calls enable a large number of actors in the sector to ideate, establish consortia, and develop their proposals. The other type of call, innovation ideas calls, it has a narrower focus, and it's mainly focused on developing and promoting innovative ideas among small and medium enterprises and small and medium-sized municipalities. In these kinds of calls, you can also come with a already developed idea that needs to be proved in the market and further developed. And that is actually the case of our first project that will be presented today. This project was granted financing in 2021 in the Innovation Ideas call. Please welcome to join me on stage Sofia Malmsten from Parametric Solutions.
Thank you very much.
Welcome, Sofia.
Thank you, and thanks for the introduction.
You are, Sofia, you're CEO and co-founder from Parametric Solutions. What is the project that you're going to be talking about today?
So we did a project within Smart Built Environment connecting generative design, which is basically algorithmic design, with geodata. And we did that together with a project partner in the Innovation Idea program. And yes, this is what I'm going to present.
Thank you. Thank you, Idea.
Thank you very much. Yes, so the title of the project is Generative Design and Geodata. And just a short background. I have a background as an architect. I've been studying architecture for many, many years, but I don't work as an architect today. Today I run a startup called Parametric Solutions. And it is currently a small company, but with a big vision of improving our industry. And today I'm going to tell you how we work with that. So the construction industry is facing a lot of different challenges. We're facing long lead times, we're facing inaccessible data, and we're also facing suboptimal processes. And why is that? As mentioned, I've been working a lot as an architect, and designing buildings is a really complex process. In early stages, there's a lot of information that we don't even have access to. But we still need to find solutions and take care of so many different aspects and parameters. We always have to think about good floor plans. We need to think about accessibility rules, groundwork, sightlines. And this list of aspects just goes on and on. And every year this list becomes longer and longer. So being an architect or designing buildings can be summed up in one word, which is complexity. And in order to work with this complexity and to solve this, we have to work with fundamentally new ways. So the way we're dealing with this is that we describe buildings with code, and not with statical drawings as we normally do. And what I mean by that is that we write algorithms that iterates over a design scope and generate a variety of building options in just a few minutes. And we extract data points and evaluate the different design concepts that we've generated. In order for people to interact with this technology, we have developed a SaaS-based platform, and our goal is to create building proposals in just a few minutes. The approach that we're using is basically, as you can see here, we have a few inputs. We call it elements, which is basically standardized units or apartments. We have preferences like how many bedrooms do I want, how many one bedroom, how many two bedroom, and so on. And then as the last pillar here, we have the geodata or the site information. These three aspects goes into our algorithms that starts generating not only one design proposal, not only two, but we generate up to hundreds of different options. And all of these options are evaluated based on certain KPIs and metrics. And based on data, we can pick a solution to continue working with. So as mentioned, we have standardized units, and what we do with them is that we define the rules, interfaces, and connection between these units. So this unit can be connected to this one, and this to this. So we set up rules and connectivity graphs, basically. And we can then, when we have the rules in place, we can then start iterating. This means that with a set of rules, we generate a lot of different proposals and we evaluate how many units do I get in total, how many square meters do I get, what is the efficiency of the building in terms of net internal area divided by gross floor area and so on. And we can start elaborating and measuring building proposals very early on. If we look at it at a bigger perspective, we can also look at larger sites and do site divisions and volumetric studies in early stages. But we can achieve a lot with this. We can quantify square meters, we can measure economical perspectives and so on. But as an architect, it's really important to also take the site into consideration. We need to generate proposals that are site-specific and that takes into consideration the information of the context. So therefore, in this project, we were working with geodata. Geodata is the foundation and the prerequisite for running the algorithms on a given site. We need to take in information about the site itself, such as topography. We need to know about the detail plan. We need to analyze the site before we even start putting proposals on it. We need to evaluate stormwater. We need to evaluate the noise situation and so on. And then we can build up an environment where we can combine geodata and generative design. When we have the geodata and the generative design in place, we can then start measuring from another perspective than the economical one. We can start looking at quantifying sustainable cities, for example. We can look at climate action, and we can start measuring and comparing design. And where we believe that we do the biggest impact is actually not when we generate the options. It is when we actually team up with property developers or suppliers of standardized units and building systems. So here is an example from a property developer that we work with in Austria. They have a set of standardized units, and they also have the metadata about the different units. So they know how much one unit costs, how big it is, how many square meters it is, what it takes to produce this unit, and so on. So when we have this metadata, we can unlock the potential of business intelligence in a new way. So we can then take these units, take that into the algorithm together with the site data and the geodata, and we can start iterating. We've done similar things with a Swedish developer, Bonava, that we've been working with a lot. And they're also part of this project as a project partner. And together with Bonava, we've had a look at their single-family housing units. They have a set of different units and standardized components. And the same as before, we quantify the rules and constraints for how these units can be combined together. and also how they relate to the street and things that you don't even think about when it comes to standardization. And when we have that in place, we can again look at what are the different possibilities that you have on this piece of land with your standardized components as the inputs and also the geodata. So what we want to achieve with this project in general is that in the industry, we want to shorten the lead times. We want to increase the insights in early stages so that we can make the best decision as early on as possible. We also want to increase the creativity, because sometimes the algorithm actually comes up with proposals that you didn't even think about from the beginning. And we also want to lay the foundation for new business models and open up for new value chains in the industry. So I hope you found it interesting, and I hope that we can somehow collaborate in the future. So thank you so much, and let's co-create better cities. Thank you so much.
Thank you, Sofia. Thank you very much for a very interesting presentation. And as you were saying, generative design has the potential to really help us achieve more efficient processes in terms of time, quality, and cost in the early stages. Which would you say is the main challenge for a full adoption of this kind of technology within the construction sector?
First of all, I would say that since we generate so many options, that is a really huge challenge, because you get so many options and you understand that if I can get 10, then I can get 11 options or 12. And like taking that part into consideration is quite overwhelming for the user sometimes. So that is one aspect that is could be a challenge. And also like the relationship between stakeholders in the industry. This is a quite new way of working with design and so on. So it's also important to find like the roles and responsibilities in the industry.
I understand. You were also mentioning access to standards and standardized open geodata. If I understand correctly, it has been quite a prerequisite for
definitely
for the development of the platform.
Yeah.
What challenges have you faced along the way?
Okay, so first of all, I think there's a lot of different geodata available, which is great. There is a challenge finding the right data sets, and there's a lot of different data sources available. So finding the right data sets and add that to the platform, that has been a challenge. And also like the pricing strategies for some data sets. All of the data sets are not really open. So for a small company, it could be hard to access some data sets actually.
And the last question. The platform is, for the moment, mainly focused on Sweden, even though you already mentioned that you have customers in Austria. Yeah. Does the company have any plans on including international data sets into the platform?
Yes, we have. So we have a few data sets available at the moment, but we're currently like adding a lot of more data sets along the way to the platform. So our plan is to primarily focus on the Swedish market as it is right now, but we also have plans on expanding internationally.
Well, good luck with that. Thank you very much, Sofia.
Thank you very much.
Yes, and our next project that will be presented for us today was actually granted financing in the annual open call of 2020 to develop a prototype for a digital platform that helps organizations in the construction sector with the collection, processing, and visualization of sustainability requirement data. That prototype is actually now a commercial service, a commercial platform called InCheck. Please come up on stage, Robert Af Wettersted from RET Management and Ulf Bergvall from CoreSource Solutions.
Thank you very much.
Welcome.
Thank you.
So, Robert and Ulf, what will be you talking about today?
We have created a standard and also a cloud service for requirements, and we're going to talk about that today.
Perfect. Yeah, looking forward to that. Please, the stage is yours.
Yeah. So we can take next. Today we have requirements from many places, and you can see here, for example, the global goals and EU legislation, national legislation and industrial requirements. We have constructions companies, we have certification systems and ISO standards we have to follow up. And today we work in papers, and we want to change that. Is there anything you want to add, Ulf?
Yeah, could you quantify this? How many different sources are there for requirements?
Thousands, many thousands. We have counted them, but there's very many of them.
So it's about 150 different sources, and each of these sources have a lot of requirements and define them in their own specific way. And that's a challenge if you want to digitize this. So what we did in this project is that we gathered some of the creators of requirements here in Sweden, and we built a standard for how to structure requirement definitions, not only for sustainability requirements, but for generic requirements. And the purpose of that standard is to be able to take a requirement definition in text, divide it into smaller pieces of information objects, and also represent that structure in a format that can be exchanged between systems and tools. So the standard called REX is actually about being able to digitally exchange requirement definitions between systems. And that opens up a lot of opportunities. So what we did was that we also in this project took this standard and implemented it in the cloud solution called InCheck. And what we're doing in InCheck is that we take these different sources that produce requirement definitions and digitize them and put them in a database or a requirement library, so to speak. And by doing that, we can produce a service and deliver a service to organizations that create requirements, organizations that use requirements for different purposes, and also organizations that need to respond to requirements. So in this process flow, requirement definitions goes in one direction and compliance declarations goes in the other directions. And a creator of requirements could be a legislative organization. It could be a certification organization. A user of requirements could be a builder, a developer, and a respondent could be a contractor or an entrepreneur. And today, without this solution, this process is entirely manual, and these actors are sending emails and files with requirement definitions to each other, and that is a very inefficient way of doing it. Do you agree,
Yeah,
Robert?
absolutely. Yeah.
So this platform is also a platform for generic data sharing. So it's not only sharing requirement definitions, you can also share goal definitions, project templates for doing requirement compliance work, and also the result of compliance control, the compliance declarations can be stored in the system and shared between actors in the system. That is quite unique. And also can be shared outside the system using the standardized requirements exchange standard.
Yeah, and I would like to add that this is less stressful, because when you work with these requirements in a database, you know what you're doing. You don't have to follow up in any emails and so on. You have it in the one place. And now we have run this in several projects, and we can also do it in a digital twin. So we have all the information in a digital twin, and we can put the requirements on an entire building, or a floor, or a window, or a room. The requirement could be linked to the object, and the object could be a whole building or a piece of a building. And that way we can follow up in small details.
Could add that we also store the result of the control that is being made on compliance, the verifications that are required from the requirement creator. And what is the effect of this? Well, we see that since the requirements, especially sustainability requirements coming from different sources, are repetitive, we need to build a process that is also repetitive, and we've done that through this system. So instead of inventing the wheel every time you're going to check for compliance for a building, you can build templates for specific types of buildings and generate the entire structure for doing the compliance control in the system.
And Ulf, I can add here too, we can save a lot of money and time in doing this.
And is there something we can say about the consequences of doing this manually today?
I would say we miss several things. We don't have time to handle them, actually. It costs too much.
I believe that the Swedish Housing Agency have examined this, and in a report they pointed out that there is about 100 billion Swedish crowns every year going to waste because of the lack of good control over requirements. It's too expensive and too inefficient that requirement control isn't done, basically. So this is a way of solving that. And as we said, this is also a system where we handle a lot of data, and in a building project there could be thousands of requirements, not only sustainability requirements, that needs to be checked. And in order to manage that, this solution also provides task management. So you can assign the compliance control for a specific requirement to a specific person and follow that up on a dashboard level. And that's also a really important part of this solution. And as we said, this is being used now as a commercial product. And just to show you some of the data, these are the global goals that can be shared in the platform, and you can also connect the requirements that you set towards specific goals. An example of BREEAM, a certification system that is quite common internationally, and here we have divided the 392 PDF pages into smaller information objects, each object representing a requirement. And as I said, there are different solutions for going on from a high dashboard level and drilling down into specific projects and phases of a building project, and to be able to see with traffic lights if there is a problem with requirement compliance, for instance. If there is a need for more information, then please visit these sites about InCheck and about the standard. Thank you.
Thank you very much, Robert and Ulf.
Thank you.
Thank you. Well, as you were saying, there are these driving forces like, for example, the global goals, and you have the EU taxonomy regulation, and all these driving forces that drive the need for these kind of platforms and tools on an international level. If I understood correctly, InCheck is mainly focused on the Swedish market for the moment. Do you have any plans on expanding internationally anytime soon?
Well, both the standard and the platform are designed for international use. So, for instance, the user interface of the solution is in Swedish and English, and you can define requirements in various languages. So we covered that already. But we'll try to fix the Swedish market first, and then we'll see how it goes.
We were talking about the Japanese earlier today. Yeah, at lunch. We said we could manage even Japanese.
Okay, interesting. In which ways can this platform help companies be more efficient and effective in achieving environmental objectives set in the EU taxonomy?
I can answer it. It has to be very easy. Today it's too difficult, and it takes too long time. And these data tools has to help you, and they have to be very good. So we even take the taxonomy and break it down to requirements that is not that easy when you read the legislations. So we help the construction companies both to read the requirements and make them to a data world, then database can read it, and then it's easier to task them in the projects.
Okay.
I would like to add that requirements management is a lot about communication between people, and it still has to be that, because the requirements aren't written based on values or data. It's written with words. So it's important that we still have the communication, but we need to facilitate the communication between people and not allow them to send emails and huge files. So this is a communication solution and a collaboration solution between people, facilitating digitization to make that more efficient.
Mm-hmm. And one last question. What lessons have you learned along the way that you would like to share with an international audience when it comes to launching such a platform? Just pick a couple of them.
Yeah, I think it's the same stuff as always. Everybody wants to standardize. It's a great idea. But when it comes to actually doing the work with using the standard, people are a bit more reluctant because that is very difficult. So you need to put in a lot of work if you want to standardize your textual requirement definitions into this broken up pieces of information that the standard represents. That's a challenge to make organizations do that.
I just would like to add that these sustainability issues won't be done if we don't digitalize, because there are so many and it's so difficult and it costs so much money. So I think we call it a tsunami coming up. And to handle that and make it, we have to work with data in this way. Yeah.
Okay. Thank you very much, Ulf and Robert.
Thank you.
Thank you.
You.
Thank you. Our third and last speaker for today, his project was actually granted financing in a strategic initiative, which means that it has been a broad process that has included many stakeholders, and this project shows many benefits for a large amount of stakeholders in the sector. The project focuses on boosting the digital transformation of construction sites by using digital technologies and implementing them in ongoing construction projects. Welcome, Claes Henschel from NCC.
Thank you, Christina. It's a pleasure to be here.
Thank you. Claes, you're Digital Innovation Manager at NCC. What is your role in the ongoing project?
My role is to facilitate NCC's collaboration with technology partners and academia, and then to use digitalization to improve the construction industry's sustainable performance.
There are several testbeds going on within the project. Is that correct?
Yes.
What challenges is it that you are addressing in the different testbeds, and what digital technologies are you using to overcome these challenges?
Yeah. The main challenges are to reduce climate impact, improve health and safety, and increase productivity. But none of these are allowed to be achieved at the expense of the others. And the technologies that we use to address these challenges are Internet of Things sensors, building information models, AI, and connectivity. And then we combine these technologies into innovative solutions like digital twins and smart workwear.
Oh, wow. Interesting. When you say digital twins, digital twins have a large impact in the way we work when implementing it, the way construction workers work and site managers and so on. How have you addressed the soft parts of this new introduction of the technology? How have you handled the soft parts of the change in the project?
Yeah, I'm glad you asked, because we believe that humans, they will continue to play a key role also in the digitalized future. So that is why we use a human-centric approach for all our development. So before we even start to ideate for solutions, we have to look at what are the problems from the end user's perspectives. What are the jobs to be done? And what are the pains that they experience with existing ways of working? And what are the gains that they are hoping to get? And then we create concepts that we try out with early adopters. So we let them steer the direction of the development, so that we first can create and then validate useful and valuable solutions.
Very, very interesting. The results or the technologies that you're that you are testing and implementing in these testbeds,
Yes.
they are actually results from a previous strategic initiative that was driven a couple of years ago, which is called connected construction sites. It's amazing to see that if you take the amount of actors that were involved in the previous project and the ones that are being involved in the ongoing one,
Yeah.
it's almost over 60 stakeholders that have been engaged,
Yeah.
which means that it's a lot of know-how being accumulated.
Yeah.
In what sense, in which ways could this know-how be interesting for the international audience to get to share with?
That's a really good question. And our experience and that we have learned that in order to solve these really complex and complicated issues, it's imperative to innovate through partner ecosystems with complementary competencies. And with the shared vision, we set out to explore the unknown through agile iterations. And this is key to be able to create truly unique, attractive and sustainable solutions. And I am totally convinced that this approach is not true only for construction, but for all industries and nations.
I agree, absolutely. Could you please tell us a little bit, what are the organizations that are being involved at the moment in the different testbeds?
The organizations right now, it's Linköping's University. And then we have a smart workwear company called Svanholm Technologies. We have a company called Elbjörn and Brinja. And also a company called Shark, who has a solution called Building Cloud.
Okay. So it's very different. They come from different parts of society. So it's
Definitely.
triple helix mindset,
Yeah,
so to
exactly.
say. Well, thank you very much, Claes, for being with us today. It was very interesting to learn a bit more about the ongoing project. And thank you, of course, all the previous speakers. For you watching us today, I hope this seminar has sparked your interest and your curiosity on the Swedish Innovation Program Smart Built Environment. Please don't hesitate to reach out to us if you have any questions. We would be delighted to hear from you. Thank you very much.